The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Welcome back, children. So, are you all taking care of your health? As a proverb says, he who has health has hope, and he who has hope has everything. Okay, so take care of your health. It's almost 40 degrees outside. Take plenty of water and include citrus fruits in your diet. Okay, children? How do we feel this heat? Have you ever thought? Yes, the ultimate source of energy is sun. Sun provides us heat, light and energy. The heat from the sun radiates on planet Earth and we feel hot. So, isn't it right? So, what happens here? The energy is or the heat is being transferred through air, isn't it? And it reaches the planet Earth and we feel heat. So, here what happens is heat transfer is taking place. So, in this chapter we are going to study the different methods of heat transfer. Okay? We all know that all the substances in this earth or in this universe is made up of matter, and matter exists in three states: solid, liquid and gas. And all these matter are made up of very small tiny particles called molecules. And how are these molecules, or how do we distinguish these three different states on the basis of molecules? Yes, I have a small representation here. In case of solids, the molecules are tightly packed, whereas in case of liquids, the molecules are loosely packed, whereas in gases, they are very loosely packed. So, the circles you see inside the boxes are molecules, they represent molecules. So, you can see here, in case of solids, they are tightly packed, in liquids they are loose, and in gases they are very loosely packed. So, this is the case of molecules in these different states of matter. So, we will take an example of a spoon. Look at the picture. A spoon is being heated here using a spirit lamp. The heat from the flame reaches the spoon and the spoon gets heated. So, here there is an energy transfer or heat transfer from the flame to the spoon. Spoon is a solid particle. So, what happens to the molecules of the spoon? Yes, first one end of the spoon gets heated. After that, slowly you will realize the spoon is getting hot on the side where you are holding, isn't it? On the other end where you are holding, that area also the spoon gets heated. You will feel the heat. So, what happens here? The molecules of the spoon, which is a solid, transfer energy from one end to other end. So, this is also heat transfer. Such heat transfer we call it as conduction. So, the first method of heat transfer is conduction, which happens in solids. How does it happen? Here there is no movement of molecules, just transfer of heat through contact. So, conduction happens through contact and it happens in solids. Okay, this you understood. This is the first method of heat transfer. We will take the same example where the spoon is being heated using a flame. You have some water inside now. The spoon contains little water also. So what happens here? The transfer happens from the flame to the spoon. After that, the water inside the spoon also gets heated. It starts boiling. So what is happening here? The molecules of the spoon, which is solid, is getting heated. It transfers energy or it transfers the heat. After that, this heat reaches the water molecules. The water starts boiling, and after some time you can see water vapor being released out also. Here, what happens is the molecules inside the water, which is a liquid, starts moving very fastly because they have got energy, that is heat energy. They start moving very fastly, and some of them turn into water vapor too. Because they become light, they start expanding and the water vapor rises. So here the transfer is because of the difference in density of these two substances, that is the spoon and the water. Which is more dense? Is it the spoon or the water? The spoon is tightly packed and it is very dense, thick, whereas water is loosely packed and it is a little lesser dense than the spoon. So because of the difference in density of particles, heat transfer takes place, and such heat transfers we call it as convection. So how does convection take place, or how does heat transfer through convection takes place? Because of the difference in density. And where does it take place? In case of liquids and gases. And the third method of heat transfer is radiation. So we are experiencing this radiation every day, isn't it? So how does it happen? So we will take the same example where the spoon is being heated and the spoon contains little water also. Here what happens? The flame from the heat or the heat from the flame. What happens? The heat from the flame transfers to the spoon, which is a solid, and the heat from the spoon gets transferred to the water. Meanwhile, the people who are standing near this activity, they also experience some heat, isn't it? Because two types of energy transfers are happening here, isn't it? Conduction and convection is happening here. So the child or the person who is standing near to this activity will also experience some heat from the flame as well as from the spoon. So here there is a transfer of heat through in the form of waves. So some sort of waves are also getting, heat waves are being transferred in and around that particular area, and that heat transfer we call it as radiation. So it is happening through waves, and this happens only in case of gases. So these are the three methods of heat transfer which we are going to study in this chapter, and lots of activities and examples are given in your textbook which we will analyze one by one. Okay children? The first activity is, as I mentioned earlier, a spoon is being heated here. The heat gets transferred from the flame to the spoon and later on to the water, and water starts boiling. That is the first activity. The second activity, you can see two children. The girl is holding a thick, long folded paper and she is heating it. Whereas the boy, he is holding an iron rod and heating using a flame. In both these cases, heat transfer is there. Yes, the girl who is holding the or who is heating the long thick folded paper, she will be burning the paper, but the end where she is holding, she won't feel the heat. Whereas in case of the boy who is heating the iron rod, once the iron rod starts heating, immediately he can feel the heat to the end where he is holding the iron rod. So, what do you understand from this activity? Here, some substances they conduct heat or they transfer heat very fastly, and such substances are called as good conductors, whereas other substances or other materials, they do not transfer heat, they just burn. So, they do not transfer heat. Such substances are called as poor conductors. So, we can classify materials into good conductors and poor conductors. We have a tabular column in your textbook, yes. Here we can classify things into good conductors and poor conductors. So, which are the good conductors? Tell me children. Of course, we have seen an example of iron, copper, aluminium, tin, zinc. All these are good conductors. So, you can note it down in the textbook itself. So, which are the good conductors? Aluminium, copper, iron, tin and zinc. These are good conductors. So, which are poor conductors? Yes, you can see which are poor conductors? Paper, as the girl burning the paper. So, paper, plastic, rubber, wood. These are all poor conductors. So, this is the classification of materials into good conductors and poor conductors. Children, often we see in kitchen the vessel which is used to boil the milk. Yes, we can hold it easily because the part where we are holding will be black in color, isn't it? So, even though the milk is boiling, you cannot feel the heat here in the area where you are holding because it is made up of bakelite. Yes, which is also a poor conductor of heat. The same bakelite is used in cookers also. Even the cooker is boiling hot, you can hold it because the portion where you hold is made up of bakelite. So, I hope you understand there are poor conductors and good conductors. One more activity is given in the textbook where you use an hacksaw. Yes, in this hacksaw, 3 pins are fixed using wax. Now, this hacksaw is being heated here. So, what happens? Which pin will fall first? Yes, the heat from the flame gets transferred to the first end or the top end of the hacksaw. The heat is getting slowly transferred. It reaches the pin, the first pin which is attached with wax. The wax starts melting and the pin drops off. Slowly the heat is transferred to the second pin, to the portion where the second pin is fixed with the wax. The wax melts and the second pin drops. After that, the heat transfer reaches the portion where the third pin is fixed with the wax melts and the third pin falls finally. So, all these 3 pins will not fall simultaneously. One by one they will fall according to the transfer of heat. Okay children? Now, we understood that heat transmission is taking place in solids and that is called conduction. Okay? We understood that. Now, is this transmission or heat transmission, does this take place at the same rate for all the good conductors? We have studied about good conductors. Which are good conductors? Iron, copper, aluminium. Now, we will take 3 rods which are made up of iron, copper and aluminium, okay, as shown in the textbook. So, these rods you have to fix 3 pins in all the 3 rods using wax. Now, they are placed on wooden blocks and you give heat in between, in the middle area. So, what happens? Which pin will fall fast or which pin will drop first? Yes, you can see that the pin attached to the copper rod will fall first. After that, the pin attached to the aluminum rod is going to drop, and finally the pin attached to iron rod will drop. So here you can see the rate of heat transmission varies. Yes, first it is going to be copper, second aluminum, and after that iron rod. Okay children? Children, you have understood about conduction. What is conduction? Conduction is a form of heat transfer which happens through contact, and there will be no actual movement of molecules, and moreover it happens in solids. Now we will study about convection. What happens there? What is the sort of heat transfer there? We will study that through an activity. Take a round bottom flask as shown in the picture. We are taking a round bottom flask. The flask is being heated. Before that, what should you do? You should take some potassium permanganate crystals, cover it with an aluminum foil, make a small hole and drop it inside the round bottom flask. Now you know that potassium permanganate dissolves when you put in water. Now when the flask is being heated, that particular area where the heat transfer takes place, the water present in that particular area gets heated, and now those water molecules will start rising up, and the cold water which is not yet heated will reach that place. So what happens is, the potassium permanganate crystals which slowly dissolves, that also will start rising up. So you can see the movement of violet colored water. Potassium permanganate is violet in color. Okay, when it dissolves it will give a violet color. So you can see a violet colored liquid moving upwards. So why is it that happening? There is a movement in the molecules of water. We know that water molecules or liquid molecules are loosely packed. So once they get heated, or once there is a heat transfer, these molecules starts moving. So such heat transfers we call it as convection. So in case of convection, there is actual movement of molecules because of the difference in density, and it happens in liquids as well as gases. Once the water starts boiling, you can see some of the water molecules getting evaporated also. So that is also convection. So what is convection? Convection is a method of heat transfer where there is actual movement of molecules because of the difference in their densities. It happens in liquids as well as gases. Children, now we will study about radiation. For conduction and convection, a medium is required. For conduction, a solid medium is required. You require a medium. Whereas in convection also a medium is required. It may be air. Okay. Whereas in case of radiation, you can feel the heat, the sun rays reaching us. We don't have a medium here. It passes through space and reaches the atmosphere. There is no medium required here. So in case of radiation, particular medium is not required. This just because of the waves, it gets transferred to the different areas or different regions, and it reaches us. We can feel radiation when you stand near an oven or near a fireplace also. Children, you know that when the air is getting heated, the air molecules will obviously rise up. But you can feel the heat when you stand near a fireplace or when you stand near an oven. So how does it happen? Here, no particular medium is required. The energy is getting transferred as a wave. So through the form of waves, it reaches us. Always, a smooth surface will reflect good radiation, bring out good radiation. So we receive heat from the sun through radiation in the form of waves. For radiation, no particular medium is required. Whereas for conduction and convection, a particular medium is required. In case of radiation, no particular medium is required. Radiation takes place through the form of heat waves, and it happens only in gases. Okay children, now we have studied 3 types of heat transfers. They are conduction, convection and radiation. There is a tabular column given in your textbook. Shall we read? In case of conduction, the mode of heat transfer from one end of the material to the other without the actual movement of molecules. In convection, the mode of heat transfer by the actual movement of molecule in liquids and gases. Whereas the radiation, the mode of heat transfer from one place to another without the help of medium. Now we can easily distinguish between these 3 methods. For conduction, conduction takes place in solids. There is no actual movement of molecules, isn't it? Whereas in convection, there is actual movement of molecules because of the difference in their densities. Whereas in case of radiation, radiation never requires a medium. The heat transfer takes place through heat waves and it happens only in gases. Okay children, I hope these 3 methods of heat transfers are clear for you. Children, we have studied about conduction, convection and radiation. Now how do we implement this in our day-to-day life? Yes, often you can see tea and coffee being preserved in flasks. Likewise, food also, the cooked food is kept in thermalware or induction cooker or casseroles. Instead, you take tea in a silver cup or silver glass, or the food, cooked food in a steelware, in a plate, open plate. What happens? After a few minutes, maybe 5 to 10 minutes, the tea or coffee gets cold and the food taken in an open plate also gets cold. So what happens here? The heat is lost through conduction or convection, isn't it children? So how do we preserve food, or what is the mechanism seen in flasks, that is vacuum flasks, and casseroles or thermalwares? How do we implement these 3 methods of heat transfer here, and how do we preserve our food? How do we keep our drinks, beverages and food hot? We will see that. Children, now hold a pencil in your hand. We are going to fill the tabular column. So, in the parts of a thermo flask, we have taken a thermo flask as example here. Okay, the glass vessel and lid, what does this do? What does it, how does it help us? Here, heat transfer in the part of use. In the first column you can write, heat transfer through conduction will be less. Here, because of glass vessel and lid, heat transfer or heat loss through conduction will be less. Write it down, heat transfer through conduction will be less. Okay children, the next one is the vacuum between double walls. You can see a vacuum between the double walls in thermo flask. So how does it help us, and or what is the use? Here, the loss of heat through convection will be less. Heat transfer through convection will be less. Note it down children. And the third part is inner surface is coated with silver salts. You can always see the thermalwares and the induction cookers, all that cookers, rice cookers and flask, a silver coating will be there. What is the use of this silver coating? Yes, here the heat loss through radiation will be less. So these are the uses. Note it down in your textbook. Children, we have finished studying about conduction, convection and radiation in case of solids, liquids and gases. What actually happens when there is a heat transfer? Is there any change in solids and liquids? Shall we study that? Yes, we have an activity in your textbook which shows the thermal expansion in solids. Here in this activity you can see a cardboard sheet is taken, the middle portion of the cardboard sheet is removed. It is fixed with the 2 aluminum sheets using screws, and these aluminum sheets are connected to a circuit and bulb, that is bulb and battery. A circuit is being done here. So once the aluminum sheets are heated using a flame, what happens? The aluminum sheets expand, the circuit gets completed, energy is absorbed and the bulb starts glowing. So what happens here? Once the metal is heated, metal is a solid, isn't it? here the metal used is aluminium. So once the metal is heated or the solid is heated, the solid expands because of thermal expansion. This we call it as thermal expansion of solids. So here expansion takes place and the circuit is completed and the energy is taken and the bulb starts glowing. So when you heat solids, thermal expansion takes place, expansion takes place. Similarly, when you take off the flame, the contraction takes place. The aluminum plates come back to their original position. So, and the bulb will stop glowing also. So, thermal expansion takes place when you heat it and contraction takes place when you withdraw the heat. So, does it happen in liquids? Yes, we have one more activity which shows where an injection bottle is taken and colored liquid is filled with the injection bottle. Now, you take a refill, empty refill of a pen and fix it, insert it into the injection bottle. Now, this arrangement is inserted in hot water. So, what happens? The colored water inside the injection bottle slowly rises up and enters the refill. So, what happens here? The molecules of the colored water expands and rises up. So, here also in case of liquids also expansion takes place. When once you remove the injection bottle, this particular setup from the hot water, the colored water returns to its bottle itself. So, there contraction takes place. So, thermal expansion takes place in liquids also, and once you take off the heat, contraction takes place. Okay? So, expansion and contraction will take place in both solids and liquids. Children, I hope you understood this video session. If you have any doubt, you can always call me. Okay children, let me wind up this session. The remaining portion will be taken in the next video session. Thank you. Bye and take care.